Welcome to today's Explainer. We're mapping out the massive, rapidly shifting landscape of artificial intelligence as it stands on July 14th, 2026. And honestly, we're looking at a fascinating collision right now. On one hand, you've got this absolutely unstoppable software force, driven by just unprecedented capital and ambition. But on the other hand, we're hitting a wall, the literal, immovable object of our planet's physical realities. So today, we're tracing this whole story, all the way from staggering macroeconomic projections right down to highly efficient microchips literally floating in space. Let's jump in. Here is our roadmap for today. 1. The trillion-dollar AI economy. 2. Physical and power limits. 3. Solving the hardware bottleneck. 4. Regulating the AI frontier. And 5. AI in the real world. $5 trillion. Let that sink in for a second. To put that into perspective, that is actually larger than the entire GDP of Japan. That's the sheer scale of the annual global investment currently being projected by SoftBank CEO Masayoshi Son. He's talking about the money needed to fund global AI infrastructure. You know, the physical hardware, the massive data centers, and the immense energy demands every single year. And he is fiercely defending this rapid expansion. By calling questions of an AI bubble foolish, Son is setting an incredibly aggressive, really high-stakes tone for the whole ecosystem. The goal here isn't just to make better enterprise software anymore. The mandate is to literally build out a superintelligence economy by the year 2040.
Section 1, the trillion-dollar AI economy.
We're actually seeing the fruits of this massive investment right now. Apple has officially released the first public betas for iOS 27, iPadOS 27, and macOS 27 Golden Gate. They're pushing a heavily redesigned, fully conversational Siri platform to billions of users within their ecosystem. Hey, hopefully this means it'll finally set a timer correctly on the first try. But jokes aside, make no mistake, this represents the absolute largest real-world test of upgraded deep agentic assistant software to date. It's the AI economy quite literally in the palm of your hand, operating on a truly global scale.
Section 2, hitting physical and power limits.
Because this unstoppable digital expansion, it's slamming right into the immovable object of physical reality and climate goals. In New York, Governor Kathy Hochul just signed a first-of-its-kind state moratorium, completely suspending new environmental permits for data centers exceeding 50 megawatts for up to an entire year. For context, 50 megawatts is enough to power tens of thousands of homes. Regulators are genuinely struggling here to balance the state's climate goals with the immense electrical demands required to run these new AI compute clusters. We are quite literally running out of power to feed the software. Section 3, solving the hardware bottleneck. Enter the concept of chiplets. Basically, these are modular components utilizing advanced packaging technology. A San Jose-based hardware startup named TYL Semi just emerged from stealth mode, armed with $43 million in early-stage funding to build exactly this. By manufacturing these modular chiplets, they're aiming to explicitly bypass the processing limits and thermal hurdles of modern AI workloads. So, in other words, they're engineering physical workarounds to circumvent the exact problems causing those environmental bans like the one we just talked about in New York.
Section 4, regulating the AI frontier. Now, societal safety and the push for federal oversight are introducing another major point of friction. It's basically building a structured pause into the whole development cycle. Google DeepMind CEO Demis Hassabis has proposed creating a US-based, independent regulatory body, kind of model after FINRA in the financial sector. Under this framework, once developers finish building a frontier-class model, they can't just release it into the wild anymore. They'd be required to submit it to this new agency for a rigorous 30-day safety review before any public deployment. It's a massive shift from the old move fast and break things mentality to a mandated structural oversight.
Section 5, AI in the real world. Despite these bottlenecks, we're seeing staggering valuations across completely different sectors as this technology matures. Take Chai Discovery, for instance. It's an AI biology startup that just raised a $400 million round, propelling it to a $3.8 billion valuation for their pharmaceutical drug discovery models. Contrast that with Flex, a fintech developer targeting mid-sized business banking. They just doubled their valuation to $1.2 billion in only 6 months by rolling out automated AI payment systems. The sheer velocity of capital here shows just how eagerly the market wants these real-world integrations, regardless of the physical limits. And this impact goes way beyond just venture capital. We're seeing diverse applications taking root simultaneously across global infrastructure.
For example, the AI Coalition for Social Impact, which was convened by the tech firm Blackbaud, launched a free national certification program to train nonprofit professionals on safely governing generative AI. Meanwhile, Microchip is launching a specialized SDK for space environments, and the government of Alberta is utilizing AI for massive infrastructure security.
Actually, the efficiency gain in that government application is absolutely astonishing. The Canadian province of Alberta used Claude's autonomous agentic software to scan 466 million lines of government code. This spanned across 27 different ministries. The AI proactively identified security gaps and then actually implemented tested software fixes to resolve billions in legacy cybersecurity debt. And get this, it accomplished all of this in a record 20 hours. Almost overnight, massive human bottlenecks were bypassed entirely by this agentic software. It's a real game changer.
So what you should really take away from all this is the ultimate contrast we're currently experiencing in the tech sector. Here on Earth, AI is triggering environmental strain and legislative halts, like that New York ban, because it simply demands too much power from our conventional grid. Yet, at the exact same time, Microchip is utilizing model compression and sparse neural networks, essentially stripping away the unnecessary digital fat from the AI's code to run high-efficiency, low-power vision and navigation systems directly on satellites in orbit. We are simultaneously hitting the absolute ceiling of our power grid on Earth while successfully running highly efficient superintelligence in the vacuum of space. It's just wild to think about. Which brings us right back to where we started today, the tension between our boundless digital ambition and our very real physical friction. As AI slams into these real-world limits, the strained power grids, the new regulatory bodies, the thermal hardware bottlenecks, are we truly ready for Masayoshi Son's $5 trillion superintelligence economy? It's a massive question, and honestly, it's the one that will dictate the next decade of technology. Thank you for joining me for today's Explainer. I hope this gave you a clear, focused understanding of exactly where we stand today. Keep your eyes on how these physical bottlenecks evolve, and I'll catch you next time.